Hi everybody, it's Dr. Ramey. Welcome to my office. I thought I would make a short tutorial on metric system conversions and dimensional analysis. So let's work through some practice problems. First, I do expect you to have certain metric prefixes memorized and their conversion properties. For example, I would expect you to know that 1 gram equals, say, 1,000 milligrams, right? I would expect you to know that 1,000 kilograms equals well, it actually equals 1,000 grams, right? So in other words, 1 kilogram equals 1,000 grams, okay? So that brings me to another point that I wanted to mention, is sometimes you need to use scientific notation to represent a number. For example, this is a million, right? 6 zeros, okay? So if you have an answer that comes out as a million, you would not want to write it with 6 zeros. You would want to write it in scientific notation. So that equals, okay, in scientific notation, 1.0 times 10 to the 6th grams, okay? So you can see there are 1, 2, 3, 4, 5, 6 zeros. So there is where that 10 to the 6th comes from, okay? So you can think of this as how many zeros there are after the decimal place here, okay? So if you have a very large number like this, you would need to have your answer in scientific notation. Okay, and if I give you a basic question like, 5 kilograms equals how many grams, okay? I wouldn't give you these conversions. I wouldn't give you this conversion or this conversion. Again, I expect you to know that. So you might be able to do that problem in your head, especially when you get more comfortable with the metric system. And you might say, well, I know that 1 kilogram equals 1,000 grams, so 5 kilograms must equal 5,000 grams. Okay? If you are not comfortable doing it that way yet in your head, then a more surefire way to do it is to erase this, is to set it up as a dimensional analysis problem. So when you're setting up a dimensional analysis problem, it's best to always start with what you're converting from. Okay, so we're converting from 5 kilograms. So we'll write 5 kilograms. And I'm going to put it over 1 because that's going to help me set up my dimensional analysis equation. And now I need my conversion factor. Now, again, you need to know that 1 kilogram equals 1,000 grams. Okay, and we're not really talking about grams here. We're really talking about the prefixes and how to convert from one prefix to another. The prefix is kilo, right? So this would be a problem, the same issue if I was saying convert from 1 kilometer to a meter, okay? It would be the same 1 to 1,000 ratio or conversion, but instead of grams it would be meters, okay? So the unit doesn't matter as much as the prefix, and the conversions between prefixes matter. Okay, so 5 grams, we're trying to get to grams. I know this conversion because I've memorized it. So I can write this one of two different ways. I can write it as 1 kilogram. Let me do it up here actually. I can write this as 1 kilogram over 1,000 grams. But that doesn't work for my dimensional analysis problem, right? Because I want what I'm converting from, I want that to cancel out, and I want to be left with what I'm converting to, which is grams, okay? My kilograms don't cancel out here. If I were to do this problem my answer would be 5 kilograms squared over 1,000 grams. Well, that's certainly not the answer to this problem. So what I know when that happens, I know that I need to flip this conversion right here, okay? So you can write it either way depending on what you're trying to convert from. So I can write it as 1,000 grams over 1 kilogram, okay? Now, before I do any math, I'm going to double check. Do my kilograms cancel? Yes. Am I left with grams? Yes. So now all I got to do is the math. 5 times 1,000 divided by 1 equals 5,000. That is not the correct answer. 5,000 grams is the correct answer. Okay? Always put your units. Always put the unit of measure after the number. Okay, so this would be okay. I would accept 5,000 grams, and I wouldn't give you any grief or take off any points for not having it in scientific notation. Okay, but just to reiterate, okay, 5,000 grams equals, if I were going to write this in scientific notation, I would put 5.0 times 10 to the something. Well, the something is how many zeros there are. 1, 2, 3. So it'd be 5.0 times 10 to the third grams. Okay? So these two are equivalent. This is scientific notation. This isn't. Larger numbers, like when you've got 4 or more zeros, for example, are best given as in scientific notation. Okay, so let's go through another conversion problem here. And you definitely are going to get some of these problems on a quiz, okay? In addition to being able or having to do several conversions in the lab report, which of course are going to be graded. Okay, so convert, let's say, how about 5,820 milligrams to grams. You know what, I'm going to use something other than grams, so you don't think that we're always working with grams. So I'm going to say milliliters to liters. Okay, so convert 5,820 milliliters to liters. All right, so what I would suggest that you do now is pause this video and work this problem on your own, and then when you think you've got the correct answer, unpause the video, start playing it again, and then I will walk you through how to solve this problem, and hopefully we come to the same answer. Pause now. Okay, hopefully you did that. Now let's walk through how to do this problem. Well, if I were to ask you this on a quiz, I'm not going to give you the conversion factor because I expect you to know that 1 liter is equivalent to 1,000 milliliters. Okay? So using this information, I can easily solve for liters up here. Again, always start with what is given to set up your dimensional analysis problem. 5,820 mils over 1. That gets me going on my dimensional analysis problem. And now I just need to figure out how to set this up. Okay, do I have liters on top or do I have milliliters on top of the conversion? Well, if milliliters is on top here, then milliliters better be on the bottom here so they cancel, right? So I'll put 1 liter over 1,000 mils. Now I'm going to double check and make sure I did it correctly. I do that by making sure that my mils cancel and I'm left with what I want the answer to be in, which is liters. That checks out. Now I'm ready to do the math. So 5,820 divided by 1,000 is 5.82 liters. And that is a good answer. No need to convert to scientific notation. in this case. So hopefully you got 5.82 liters. Now let's go do a practice problem, a couple of problems that are a little bit more difficult. Okay, a little bit more difficult. How about converting from let's say 25 decigrams to let's go to micrograms. Okay, 25 decigrams to micrograms. Okay, so this is the point where you should pause the video, work the problem on your own, and then unpause the video. So pause now. Okay, let's take a look at how to set this problem up. Again, you're doing conversions within the metric system, so I expect you to know the conversions for these from one of these prefixes to the other within the metric system. For example, I expect you to know that 1 gram is equivalent to 10 decigrams. I expect you to know that 1 gram is equivalent to 1 million micrograms. Okay, so you need to know these two conversions right here. Now, once we do that, we can set the problem up. So always start with what you're given. Your 25 decigrams. So 25 decigrams over 1. Now I'm trying to get to micrograms. Okay. When you get more advanced with the metric system, you can convert directly from decigrams to micrograms. However, most of you probably aren't there yet. So I would recommend always setting up a multi-part dimensional analysis problem and solving it that way. And what I mean by that is, well, I don't have a conversion here from decigrams to micrograms, but I have a conversion here from decigrams to grams. And I have a conversion from grams back to micrograms. So I want to get to micrograms. Well, I can do that. All right. First, I want to go from decigrams to grams. And I want decigrams to cancel. So that needs to be on the bottom in this case. So 1 gram over 10 decigrams. Okay, double check. Do the decigrams cancel? Yes. I'm left with grams on top. So I am on the right track. Now, do I have any way to convert from grams to micrograms? I want the answer in micrograms. And I know that 1 gram is equivalent to 1 million micrograms. So I want my grams on the bottom of the conversion factor here. So I'm going to put my micrograms on top over 1 gram. I'm going to make sure that those grams cancel. The only unit that I'm left with is micrograms, which is what I want the answer to be in. So that once I've checked that, I know that I've set my problem, my dimensional analysis problem up correctly. Now, all I've got to do is the math. All right, 25 times a million divided by 10. Okay, so if I give you a problem like this, obviously I'm going to allow you to use a calculator, right? And when you do all that, and if you don't have a scientific calculator, you may have to actually put in 1 with 6 zeros. So 25 times a million divided by 10, and that ends up being 25 million divided by 10 ends up being 2.5 million. So that would be 2.5 times 10 to the 6th. That is not the correct answer. Remember, 2.5 times 10 to the 6th micrograms is the correct answer. Okay? So when you do it in a non-scientific notation calculator, again, it's going to be, it end up being, it's going to be 25 million. Okay, 25 times a million is 25 million. 1, 2, 3, 4, 5, 6 zeros. There's 25 million. Okay, divide that by 10, And basically you drop a 0, right? So I'm going to get rid of a 0, and it goes from 25 million to 2.5 million. Okay? So this is 2.5 million micrograms. But again, I'm going to dock you points if you leave your answer like this, right? So to get full credit for the answer, when it is this large of a number, it needs to be in scientific notation. So all you need to do is figure out how many places you need to move the decimal, right? So the decimal's kind of a phantom decimal, is always at the very far right of the number. Well, we want to move that phantom decimal to between the 2 and the 5. So let's count how many numbers we have to skip to get there. 1, 2, 3, 4, 5, 6. Here's where we want it. So that means it's 2.5 times 10 to the 6th micrograms, which is what I already wrote. I just wanted to kind of show you how I got there. Once you get really good at this, you can kind of do some of this in your head. But it does take some practice. So I want to do one more practice problem with you, and then that's going to be the end of this tutorial. All right. Now so far we've done some practice problems only converting within the metric system, okay, from one unit to another, or from one prefix to another. Now let's convert from the U.S. standard imperial system, for example, to the metric system. And you have some conversion factors on page 3 of your lab manual here, right? So if I were to ask you a question on a quiz to do this, I would give you these, whatever of these conversion factors you need in order to be able to solve the problem. I would give this to you. In other words, I don't want you, and I don't expect you to memorize this. I expect you to memorize those conversions in the metric system. I don't expect you to memorize these conversions from one system to another. So I would give it to you. And let me give you an example. Let's say that I ask you to convert, if I asked you to convert 3 feet into centimeters. Okay, convert 3 feet into centimeters. So what I want you to do now is pause the video, try to solve this problem, and then unpause the video and we'll walk through it. So pause now. Okay, so let's see what you need to know to convert from 3 feet to centimeters. Well, I'm going to give you 1 inch equals 2.54 centimeters. If I were to ask you this problem, I would give you that, but that's it. But you're thinking, well, wait a minute. I'm not converting from inches to centimeters, I'm converting from feet to centimeters. Well, obviously I expect everybody to know that there's 12 inches in 1 foot, okay? So you should know that 1 foot equals 12 inches. I mean, I do expect you to know a little bit within the imperial system or the U.S. standard system. So now we're ready to go and solve the problem using dimensional analysis. So again, we're going to start with what's given, which is 3 feet over 1. I don't have a conversion straight from feet to centimeters, but I have a conversion from feet to inches, and then I have a conversion from inches to centimeters. So I can get there. But first is to convert from feet to inches, so I want my inches on top. Over 1 foot. Let's check and make sure I did that right. Feet cancel. I'm left with inches only. So far, so good. Now I'm going to go from inches to centimeters. I want inches on the bottom, so it cancels. So 2.54 centimeters over 1 inch. Inches cancel. I'm only left with centimeters. I want the answer in centimeters, so I'm done setting up my problem. Now all I need to do is the math. So, I should have had this out already, but I'm going to pull out my basic calculator. This is not a scientific calculator. And I'm going to go, there's only ones on the bottom, so I can basically ignore the bottom of the equation and multiply the top. So 3 times 12 times 2.54 equals 91.44 centimeters. And since I am making a tutorial, I just want to double check that I did that right. Excellent. 91.44 centimeters. Okay, 91.44 centimeters. Did I answer the question? Yes, I converted to centimeters. My answer is in centimeters. Do I need to convert this number to scientific notation? No, not at all. Not in this case. Okay, so at that point, I am done with this tutorial. I hope that was helpful.